clear. See what others ignore. Connect what others separate. Move while others hesitate. The world doesn't need more victims reacting to isolated headlines. It needs navigators seeing converging patterns. And Nostradamus saw you. 500 years ago, he identified this moment, 2026. Multiple plagues, failing institutions, and identified who would see the full pattern. You're here, seeing the convergence. So you're part of that prophecy. Not a passive observer of collapse. An active perceiver of transformation. The awakening isn't some future event you wait for. It's present recognition of what's already happening. That recognition starts now. With you. Seeing, understanding, acting. Think you know what a planetary alignment is? Here's the thing, it doesn't actually exist. On February 28, 2026, today, right now, 6 planets will appear to line up across the sky. Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune forming one perfect line. But that line, it's fake, pure illusion. It only appears to exist because you're here, right now, looking from this one exact spot in space. Richard Feynman taught us something radical. Observation doesn't just reveal reality, it creates it. And tonight, you're going to see the most stunning proof of that. Let me show you why. Here's what you'll see. Tonight, 30 to 60 minutes after sunset, step outside. Look up. 4 planets visible to the naked eye, forming a line. Mercury and Venus low in the west. Jupiter high in the southeast. Saturn to the south. Point a telescope. Uranus near the Pleiades. Neptune way out there. All perfectly aligned. Now stop. What you're seeing is physically impossible. Mercury sits about 62 million miles from the Sun. Neptune? About 2,800,000,000 miles away. The gap between them. Bigger than the entire width of the solar system. They never come close. Never actually line up. Jupiter has no idea where Saturn even is. Uranus and Neptune will never meet. They exist in totally separate zones of space, billions of miles of nothingness keeping them apart. But from your point of view, standing on Earth, they make a perfect line. Try this right now. Hold your thumb up in front of something far away. From where you're standing, they line up perfectly. Straight line. You, thumb, object. Now, move your head to the side. Boom. Your thumb doesn't cover the object anymore. The alignment's gone. Not because anything moved, but because you changed where you're looking from. That's the illusion. Alignment only exists for the person looking at it. The planets do the same thing. Right now, Mercury is hugging the Sun, zipping around in 88 days. Venus takes its time at 225 days. Jupiter, 12 Earth years to lap the Sun. Saturn takes 29 years. Uranus takes 84 years. Neptune, a whopping 165 years. Each one moves at its own speed in orbits that never even touch. Neptune will never get near Mercury. Jupiter will never crash into Venus. They're in totally different zones of space, like different floors in a skyscraper. And yet, tonight, you're going to see them all lined up. But tonight, from Earth, they'll all occupy the same patch of sky. Not because they've actually come close, but because of how we see things, the way light rays from distant objects line up on our perspective sphere. It looks that way. And here's where the story gets really interesting. For thousands of years, humans stared up at the sky and found patterns. Constellations, moon cycles, planet movements. We created models to match what we saw. Claudius Ptolemy, back in the 2nd century, proposed the geocentric model. Earth at the center. Everything else, sun, moon, planets, stars orbiting around us in perfect circles called epicycles. Complex? Absolutely. Intricate? Completely. Filled with mathematical adjustments to fit what they observed. And you know what? It worked. Not perfectly, but it worked for over 1,000 years. Sailors used Ptolemy's tables to cross oceans. Astronomers predicted eclipses. The model nailed what they could actually see. Then, Nicholas Copernicus showed up with a radical idea. Nope, Earth isn't the center. The sun is. And boom, all those complex epicycles vanished. Orbits got simpler. Predictions got sharper. Galileo aimed his telescope at Jupiter and spotted moons orbiting, not Earth, but Jupiter itself. Kepler figured out orbits weren't circles, they were ellipses. Newton proved it all came down to one thing: gravity. Here's the thing most people miss. Ptolemy got it wrong about what was at the center, but he got it right about what was actually happening in the sky. The stars didn't move. The planets didn't move. They kept doing what they always did. What changed was our understanding. Our description of what we were looking at. That shift, Ptolemy to Copernicus to Newton, shows something crucial about how looking at things shapes how we understand them. And nobody dug deeper into that relationship between observation and reality than Richard Feynman. Richard Feynman won the Nobel Prize in Physics in 1965 for his work in quantum electrodynamics. But his real gift wasn't just solving problems, it was questioning everything. Feynman had this uncanny ability to challenge how we think about reality, observation, and what's actually true. He once said, "I think I can safely say that nobody understands quantum mechanics, not because it's difficult, but because at its core, nature just doesn't operate the way our gut tells us it should." And he proved it with an elegant experiment that'll shift how you see tonight's alignment. Here's what he meant. First up, a machine gun fires bullets through 2 holes in a wall. A detector measures where they land. What shows up? 2 stripes. Makes sense. Second, water waves. Waves push through 2 holes. They interact on the far side. What do you get? An interference pattern. Bands of tall waves and flat water alternating. Third, electrons. An electron gun, 2 slits, a detector. Fire electrons one at a time through those slits. What happens? Not 2 stripes. You get an interference pattern, just like the water waves. But wait, you fired a single electron. Which slit did it actually go through? Here's where quantum mechanics gets weird. Each electron goes through both slits simultaneously. It's in a superposition on both paths at once until you actually look at it. Now add a detector to figure out which slit the electron really takes. Check the screen. The interference pattern vanishes. You see 2 simple stripes, like the electron chose to be a particle the instant you watched it. Hold up. Think about what that means. Observation flips the outcome, not because your detector physically shoved the electron, but because the act of measuring pulling information from the system forces the electron to pick a definite state. Now here's where it gets truly bizarre. Feynman spent years wrestling with what this meant, and he came to a radical realization. Models are tools, not facts. Quantum mechanics tells us how nature acts. It predicts things with stunning precision, but it doesn't explain why. And Feynman was totally okay with that. There's this famous interview where a reporter asked Feynman, "Why do magnets attract?" Feynman wouldn't do it. Not because he didn't know the physics, but because whatever he said, magnetic forces, electromagnetic fields, virtual photons bouncing around, would just kick the why down the road one more level. Why do electromagnetic fields work that way? Virtual photons exchange. Why do virtual photons exchange? That's how space-time symmetry works. Why does space-time have symmetry? Because it never stops. Eventually you hit bedrock. This is how nature is. We look, measure, describe, but the deep why always slips through our fingers. And Feynman was fine with that. He ditched the idea that science reveals ultimate truths. Instead, science makes maps, tools that show us reality. Maps aren't the actual place. A map of Brazil shows you roads, cities, rivers. Great for getting around. But it's not real Brazil. You can't climb the mountains drawn on paper. You can't swim in the printed rivers. Same with science models: geocentric, heliocentric, Newtonian, relativistic, quantum. They're maps of nature. Each one works in its own context. Each has limits. None is the final answer. That whole Feynman idea observation shapes what we can know. Not what really exists, fits perfectly with today's planetary alignment. Calling it an alignment is just a model, a human description of 6 things appearing in the same patch of sky from Earth's viewpoint. Practical? Sure. It lets us talk about it, plan when to watch, recognize how rare it is. But it's not cosmic fact. Watch what changes when you shift where you're looking from. From Mars, those same planets scatter in totally different setups. From Jupiter, Earth's just a speck, maybe lined up with Venus from a whole different angle. From Neptune, the inner solar system's a glowing mess near the sun can't even separate them. The alignment only shows up because you're watching from Earth. Observation creates reality, not in some cosmic woo sense, but practically, concretely. What you see depends on where you're standing, and alignment only exists because we're on Earth and decided to call that particular view an alignment. Feynman would have eaten this up. An illusion you can actually see, a real pattern born from perspective, a thing that's both true, you genuinely see it, and false, it doesn't show actual physical structure. That's beautiful. Knowing it's an illusion doesn't kill the wonder, it amplifies it, because now you grasp not just what you're looking at, but why you're seeing it that way. You hit the edges of what perception can do. You appreciate the elegant geometry of how observation works. That's the heart of Feynman's scientific approach. Don't hold on to certainties. Instead, chase better questions. Don't expect nature to make intuitive sense. Just observe, measure, describe, and accept that describing is plenty. So, what's the takeaway for tonight? When you head outside and stare up, you're not just watching planets. You're stepping into a cosmic illusion. You're placing yourself in the single spot in the universe where these 6 distant worlds look lined up. You chose to look. And in doing that, you make the alignment real, at least from where you're standing. Now, let me guide you through exactly how to witness this illusion. First, timing. The alignment reaches its peak visual impact on February 28, 2026. But depending on where you are on the planet, the best date to observe varies. If you're in São Paulo, aim for February 25. Why? The way Mercury and Venus orbit those 2 planets sitting lowest on the western horizon means they're in better spots a few days before peak. You get maybe 45 minutes. That's it. Mercury moves quick. It's not going to hang around. In Berlin, London, Beijing, or Tokyo. Go for March 1st. Being further north means the western sky sits at a better angle, so Mercury and Venus sit higher up. You'll get another 50 to 60 minutes of watching time. Up in Reykjavik or other far northern spots, hold off until March 2. The sun stays up later, and when it does set, the angles work better. All 6 planets end up technically visible. Mercury's still tough though. Now here's what shows up to the naked eye. 30 to 60 minutes after the sun dips down, get outside. Find a clear spot facing west with nothing blocking your view. No buildings, no trees. You need an open sight line to where the sun went. Look west. Low on the horizon, there's Venus. Bright. Can't miss it. The brightest thing up there except the moon. Venus is the easy one. Now the hard part, Mercury. It's tiny, dim, and it never wanders far from the sun in our sky because it orbits so close. Tonight, Mercury will sit just under Venus, even lower on the horizon. You've got maybe 30 minutes before it vanishes into atmospheric haze and twilight glow. Grab binoculars if you've got them. Hunt for a tiny yellowish spot. It won't blink like stars' planets glow steady because they're close enough for you to see their disk, even if you don't realize it consciously. Spot Mercury. You've just caught the trickiest of the 6. Swing southeast. High up, Jupiter sits there. Brilliant. Cream white, unmissable. Jupiter's perfectly positioned high enough to stay clear of atmospheric distortion, bright enough to shine past every surrounding star. Pan toward the south. Saturn's hanging there. Not as bright as Jupiter or Venus, but still easy to spot with your eyes. Pale yellow. Calm and steady. Have a small telescope? Even a basic 60 millimeters, about 2.4 inches? You'll see the rings. One of the coolest sights in amateur astronomy. That's 4 planets. Mercury, Venus, Jupiter, Saturn. All grabbing with your bare eyes. Scattered across the sky from west to south. But the alignment is supposed to have 6. What about Uranus and Neptune? This is where a telescope comes in. Plus patience. Uranus is near the Pleiades star cluster in Taurus, farther south than Jupiter. Grab a modest telescope 80 to 100 millimeters, about 3.1 to 3.9 inches. Aperture, and a star map or a phone app, and you can find it. Uranus shows as a tiny blue-green disk. Faint, but definitely not a star point. Neptune's the real beast. Way out there. Very faint. You'll want a solid telescope minimum 100 millimeters, about 3.9 inches. Ideally 150 millimeters, about 5.9 inches, or bigger, and dark skies. Neptune sits farther west than Uranus, closer to Saturn in the sky. With good magnification, it's a tiny blue speck, nearly invisible against background stars. But it's there. So, bottom line, naked eye gets you 4 planets. Telescope gets you 6, and they all sit in the same piece of sky. But rewind to what we covered. Mercury sits about 62 million miles from the Sun. Neptune about 2,800 million miles. When you gawk at them aligned, you're not seeing them up close. You're watching geometric projection. Your sight line cuts through billions of miles of empty space, grabbing light from worlds that'll never touch each other. Every photon hitting your eye traveled different distances. Some took minutes, others took hours. You're watching each planet's past, not right now. And here's a wild detail that deepens the illusion. On February 16th, just 12 days before the 6-planet alignment, Saturn and Neptune had a conjunction. They looked super close in the sky. Close enough that through a telescope, they fit in the same view. But close in the sky isn't close in space. Saturn was about 870 million miles from the Sun. Neptune about 2,800 million. Their actual gap? 1,930 million miles, more than 20 times the Earth to Sun distance. They were never close. But when you look from Earth, their orbital paths cross the same line of sight. Try sending a spaceship from Saturn to Neptune at that exact second. Years of travel to cross the non-existent gap you saw as a few centimeters in your telescope. That's what a planetary conjunction really is. Not physical closeness, just alignment from one viewpoint. Tonight's alignment is the identical thing, 6 objects instead of 2. So why care? Why drag yourself out into a cold February night to watch an illusion? Because observation builds meaning. Not in some woo-woo sense. Practically. When you decide to see the alignment, you tap into the exact drive that pushed Ptolemy to map epicycles, Copernicus to move the sun to center, Galileo to aim his telescope, Feynman to keep asking why. You realize your vantage point standing on Earth, peering out, is unique, specific, limited, and valuable precisely because of those limits. No book teaches that lesson. You have to look up and witness it firsthand. Feynman's whole life was built on this. Science isn't certainty. It's curiosity, not hunting for final answers, but chasing better questions. And planetary alignment is the perfect question. Why call it an alignment if the planets aren't really lined up? Because how we look at things shapes how we talk about them. We name what appears, not what exists independent of us. Why sweat this night if it's just an illusion? Because rarity matters. Those orbits, cosmic clocks ticking in rhythms of months, years, decades, centuries, only line up this way once in a blue moon. Next time? Could be a decade. Could be longer. When it happens next, you won't be the same. You'll have aged, seen new things, had different thoughts. The illusion stays the same. You don't. Is the alignment real? Yes and no. Observationally? Absolutely. From your perspective? Definitely. Physically real in terms of closeness or structure? Nope. That's the core idea. Reality's contextual. Truth depends on how you measure, where you're looking from, what you ask. Feynman got this deeper than almost anyone. He was cool with contradiction, welcomed doubt, kicked dogma to the curb. Tonight, when you peer up, you can do the same. Hold 2 opposite truths simultaneously without needing to pick one. Look at the planets. Soak in their beauty. See the illusion. Admire its geometry. Embrace both simultaneously. The alignment is real because you see it, and fake because there's no actual structure and skip the urge to settle it. That's science thinking at its peak. Not forcing nature into intuitive boxes, but looking, measuring, noting, and stumbling onto awe in the process. Tonight, or whenever it's ideal for your spot, head outside 30 to 60 minutes after sunset. Grab binoculars if you have them, a telescope if you own one. Pull up a star map app on your phone to hunt Uranus and Neptune. Hunt down an open western horizon. Lock onto Venus first. Can't miss it. Then Mercury just below near the horizon. Swing southeast and spot Jupiter, high and gleaming. Keep going south and grab Saturn. Telescope out, find Uranus near the Pleiades cluster and Neptune hanging west. As you watch, keep this in mind. These worlds are nowhere near each other. Mercury tiny, burned up, hugging the sun, hits 806 degrees Fahrenheit during the day, plummets to 292 degrees Fahrenheit at night. Venus wrapped in sulfuric acid clouds, crushing pressure 90 times Earth's. Jupiter, massive gas giant with storms bigger than Earth. The Great Red Spot alone swallows us. Saturn, rings of ice stretching hundreds of thousands of miles, but paper thin, only about 33 feet thick. Uranus, tilted on its side, blue-green from methane spins every 17 hours, takes 84 years to orbit. Neptune, distant, dark, winds screaming past sound speed, about 1,305 mph, fastest in the solar system. Each different, each extreme, each completely uninhabitable. But from here, from where you're standing, they line up. And that's enough. You're not watching physical reality, you're watching observed reality. And that's what Feynman hammered home. That distinction is the core of physics today. Feynman showed us something vital. Description suffices. Observation suffices. Understanding the edges of what you can know, it doesn't kill awe. It amplifies it. So head out. Look. Watch the cosmic illusion unfold. Know that you're joining an ancient human thing. Staring up, questioning, building frameworks. Chasing meaning not in absolute answers, but in endless curiosity. You're embodying Feynman's worldview. Watching without chasing certainty. Measuring without needing the ultimate why. Stepping into the illusion fully aware it's an illusion, and finding the beauty in exactly that. The alignment on February 28, 2026 isn't cosmic destiny. The planets don't give a damn. Their paths stay constant. No force cements them together. No fate unfolds. For you, though, planted on Earth, gazing up, opting to witness, it's massive. Because you're living Feynman's insight. Reality is what we measure. Models are tools. Questions trump answers. When those 6 lights scattered across the sky, apparently lined up, click in your mind, you'll grasp something Feynman hammered his entire life. The cosmos doesn't owe us anything. We owe the cosmos attention. Watch carefully. Spread the moment. Get kids, friends, everyone willing to glance up. And remember,